So adding and subtracting fractions, both adding and subtracting, follow the same pattern. So when you have two fractions, let's say 1 over 7 plus 2 over 5, what you're trying to do is you're going to try to get these two denominators equal to each other. Because you're not allowed to add, you're not allowed to do 1 over 7 plus 2 over 5. So getting these two fractions into the same denominator allows you to add and subtract. So we're going to be looking at these numbers multiples. So we're going to look at the multiples of 7 and multiples of 5. And then we're going to look at when they match up. So 7 goes to 14, 21, 28, and 35. And 5 goes to 10, 15, 20, 25, 30, and then 35. So we have our match in 35 for both 5 and 7. So what we're going to do now is we're going to multiply the entire fraction for each respective fraction. So I'm going to look at 1 over 7 right now. So to get 35 from 7, you need to multiply 7 by 5. So I'm going to multiply the entire fraction by 5 over 5. And then for 2 over 5, for me to get 35 from 5, I'm going to multiply 2 over 5 by 7 over 7. And then I'm going to write the new fractions over here. So I have 5 over 35 plus 14 over 35. And this is going to get me 19 over 35. So the reason you can't add the two fractions together, like numerator to numerator and denominator to denominator, is if I were to do that, I would get 1 over 7 plus 2 over 5. And this would be 3 over 12, and that is equal to 1 over 4. So 1 over 4 is not equal to 19 divided by 35. And if you were to do the math using the decimals and converting the fractions to decimals, so 1 divided by 7 is going to be 0.142. I'm going to put some dots because it goes further. And 2 over 5, 2 divided by 5 is 0.4. That is equal to 0.542. While 1 over 4, this is equal to 0.25. So those are not. So now I'm going to erase all of this and then do more examples of this. So I'm going to be doing 3 over 4 plus 2 over 6. So the original method will work every single time as long as you know the multiples. So do 4, the multiples of 4 are going to be 8, 12, 16, 20, and 24, and then 6 is going to be 12, and then once I see 12, I know that we have the two multiples, or the multiples for our two denominators. So then I'm going to multiply both numbers, so 4, to get 12 from 4, I need to multiply it by 3. So multiply this by 3 over 3. And then multiplying the other one, to get 12 from 6, you need to multiply it by 2. So 2 over 2. So then I'm going to get 9 over 12. 9 over 12 plus 4 over 12. This is going to get me 13 over 12, which is going to be my final answer. So when you're doing these, I would recommend writing the two denominators and then the multiples of them so you can get to it quicker, as the other method would be just multiplying the two denominators together. And what I mean by that is multiplying the 4 times the 6, and that gets us 24, and that will work every single time. And then you then multiply 4 by 6, and then 6 by 4 for those two respective fractions to get your final answer. And your final answer will be the same, 13 over 12. So I'm going to erase this, and I'm going to do a subtraction of fractions. So subtraction of fractions work very similarly to adding. It's just the only thing now is instead of adding the two numerators together once the two denominators are the same, you're going to subtract the two numbers. So I'm going to do 7 over 9 minus 4 over 3. So I'm going to write out the multiples of 9. Write 18, 27, and then I'm going to write the multiples of 3. 6, 9, and then I'm going to stop because I have technically both my multiples, 9, or that being 9. And so I'm not going to change my 7 over 9 because the denominator is already 9, but I do need to change my fraction of the denominator of 3. I need to multiply that by 3 over 3 because to get 3 or 9 from 3, you need to multiply that 3 by 3. So I'm going to get 7 over 9 minus 12 over 9, and then I'm going to get a final answer of minus 5 over 3. And I hope you can see that the two processes of adding and subtracting are virtually identical except for the fact of either adding or subtracting. And I'm going to do one more example of this. This example, I'm going to be using 2 over 2 minus 6 over 2, or 6 over 3. So I can do this two ways. I can do it how we've been doing it by converting the two denominators into the same number by writing the multiples for 2 and 3. Get 4, 6, 8, 10, and then for 3 I get 6, 9. I'm just going to stop right there because we had the two common denominators right here. And then this is going to multiply both by their respective ones. So to get 6 from 2, it's multiplied by 3. And to get 6 from 3, I need to multiply by 2. And this is going to be 6 over 6 minus 12 over 6. Get me minus 6 over 6, which is equal to -1. So in this instance, I could have either simplified the two fractions, which would have been 1 minus 2 to get. All right, that's going to be the end of the video. If you have any suggestions on future content, please comment it below and have a nice day.